I'm here with Shawn Allan from Lithos, North America. He's a VP and visiting for a machine update for Ceramco. We're going to talk about the advances in technology and lithography-based ceramic manufacturing, and where Shawn is an expert, I have some questions about what's up and coming. Welcome, Shawn.
Yeah, thank you. Thanks for having me.
I was in Germany at Ceramtech last fall and saw that Lithos has a modularized system now where you can add printers to a central computer, thereby expanding the capacity of a printer by sharing that computer. I thought that was really exciting. I like that it would really give a customer some more economy by using one unit to print in several steps, but also it seems that it may increase the throughput of a system overall, similar to perhaps even an injection molding machine. Do you see that there would be any further automation or expansions of your machines in the future? Any ideas?
Yeah, so that new concept is a combination of both the machine and software differences. So more our Serifab control software gives more flexibility in order to control multiple machines off of a single server, and make it easier to add on printing stations down the road. And then I think as we keep moving forward, I'm sure there's going to be some developments and automation of other parts of the process, especially in the post-processing, where parts come out of the printer and have to go through cleaning or switch over to starting new prints, are areas that we could see some automation developments. And I also think another area may also be in developing failure detection methods that can help in the event that you have a part that fails during a print to alert or pause or stop the run, so that can be addressed.
That's been a much awaited thing. Mm-hmm. Certainly having the things that happen during manufacturing and being able to stop it and adjust is a much needed improvement. That's a good idea. Yeah. And that's right, the cleaning of parts is a major piece of the labor that's involved, so that's a good idea. Glad to hear that. The resolution of printers comes up because that really is the fineness of the surface and general structure of the ceramic parts. Do you see that the resolution of your printers would be improved in the future?
Yes, definitely. And there are a couple different ways that we're improving resolution. So one way to do that is by taking advantage of new light sources as they become available. So our system works by curing a ceramic slurry that has photopolymers in it, mm-hmm. and they're cured by the light source. The light source we use is a projector, just like a conference room or movie projector. It has a certain number of pixels that are in it, and so depending on how large of an area you project those pixels onto, that determines how big those pixels are and what your resolution is. So in order to have a higher resolution, you need a larger pixel count. And those projection systems are coming along. So as industry develops better systems that are available for industrial use and not just entertainment, then those will be able to be worked into systems and give us either higher resolution and also possibility for larger print areas.
Oh.
Yes. So another way to deal with resolution now, though, that we've been developing is a system called the ultra high contrast vat system. So the vat is the container that holds the ceramic slurry that the light from the projector is illuminated through. And so we've made some advancements in vat design that eliminates a lot of the scattering of the light in the vat before it reaches the slurry. And as a result, we get a less light scatter. We have finer resolution of the details of the parts and features. So holes in walls and thin features are coming out more accurate and more consistent across the entire build area.
We have oftentimes the issue when a part is a little too large to print with the machine, and whether that's in X, Y, or Z direction, every part is a different shape, and sometimes you wish you could either take the part and move it on the machine so you could keep printing on it in another direction, or maybe you could print it in two pieces. How do you see the improvement in, or any ideas about how we could do that when you have a limited size for printing and you have a larger part to print with?
Mm-hmm. Yeah, that's definitely one of the bigger challenges, because we're printing with a light source that's based off of the formats of projectors, TVs, computer monitors.
Mm-hmm.
So like our standard system uses what's called the 1080p. That has a certain pixel count and also a certain aspect ratio. And so a lot of these projectors are based sort of on the wide format, which is more popular for entertainment and
Right.
movies, right? They look better on the wide format. But that means in terms of what you can print in parts, you can maybe print something that's longer, but to print a large circle is a more difficult thing to do, so you run into that problem.
Yeah.
So one strategy around that is working towards larger print areas. And there's different ways to get there through DLPs, or maybe combinations of alternate light sources that could be DLP and or laser in order to do that. So those are things that we're working on, and strategies of how to get to larger areas.
Yeah, that as far as making bigger parts, that must come up a lot. That's a ceramic material challenge as well. There is a way to make the shape and make it larger, but the larger you make a part, there's other things involved, and especially ceramic materials, then you're dealing with a larger body, and in general the possibility of the defects and so forth, and during firing especially, that in itself is always a challenge, regardless of the technology that you're using to make the shape. But it's good to hear that I think there's some potential for being able to print larger parts. Not too much larger, but sometimes it's just on that little edge where you need it to be a full 2 inches, and maybe only 1.9 is possible, and
Right. And
we encounter that sometimes.
depends on what the design needs, and also if you have a possibility to change the orientation for printing to take advantage of the larger directions or the Z height to
Right.
print. Sometimes that's possible, sometimes it's not. But I think some of the new machine strategies hopefully will help with that.
Yeah, you mentioned earlier there more of the novel technology advancements in R&D out there. You mentioned a system you know of that has several technologies combined. Can you tell me more about that?
We have a system being developed at Lithos now that will have a much larger build platform area that we have. So in order to do that, because with a DLP system, as you project onto a larger surface, the individual pixels get larger and larger. So there's different strategies to accommodate that, either with using multiple DLPs together, or combinations of maybe DLP to get the bulk area, and then laser to help improve the surface quality of the part.
Yeah, surface quality is always a very important parameter for customers. We find that the types of machine and type of technology that you're using does affect the surface quality. Have you found that there are any needs for the surface to be changed based on the direction that you're printing in? That
well, yeah, you do get different surface roughness in different orientations. In general, it's not a great difference between from the worst case to which would be printing across pixels versus printing in line with the pixels, or even in a layer where you have the smoothest surface.
Mm-hmm.
So we don't find that there's a great deal of difference in the surface roughness, but yeah, absolutely. If you need a very high smoothness, then you may want to have that surface printed in the individual layer if possible.
Okay. Shawn, do you see the speed of printing advancing more in the future?
Yeah, there's a lot of opportunities. I think once you learn how to print a particular part or type of part, there's a lot of room to optimize those printing parameters.
Like the hold times and
Hold times, how fast the machine moves through the process.
Mm-hmm.
There are a little bit of time gain to be had there's a little bit of time gain to be had from the higher intensity light sources that are out there now.
Mm-hmm.
So exposure is actually a very small portion of the individual layer cycle,
Mm-hmm.
Maybe only a couple seconds. But over a tall part with thousands of layers, if we can cut out 2, 3, 4 seconds per layer
That
with
adds
higher
up.
intensity light source, that definitely makes a difference. You're talking about hours.
Uh-huh.
One of the exciting things that we're able to do with some of the materials now, thanks to the higher intensity light sources and that ultra high contrast system VAT, is that we're able to print some materials with thicker layers now. So usually we're printing in 25 micron layers for most materials, and now we're able to print in 50 or even 100 micron layers for materials like alumina. So if that gives a good enough resolution for that part, we can cut that print time by half or even more.
That's true. We do typically run around a 50 micron layer in general, and that would make a significant improvement. To be able to do 100 micron, that would double the speed
Yeah,
at
exactly.
what you're printing.
You basically double your throughput then too.
Yeah. And you're right, there are sometimes parts which it's very likable that you can use a thicker layer, where other times maybe not so.
Exactly, yeah. Just what your tolerances are.
Yeah. Well, it sounds to me like there are a lot of exciting opportunities for this technology to be going in a more manufacturing related direction, as opposed to the slower lab scale type of process to actual faster and more efficient type of process, which is needed because our customers certainly do order more than one piece at a time, and if anything, the faster that we can print, for example, the better. And I believe that there are some comparisons with injection molding, and when we have customers doing the transition from an additively made part to a injection molded part, there's a lot to learn there still.
Right.
We'll be doing some studies on that. I know case studies have already been done, and we'll be interested to see how we may be able to, in our lifetime, have those technologies converge a little more.
Comparable, yeah.
Yeah, with higher throughputs and expandable equipment with a little more automation to it that makes it faster and more efficient. It's really exciting right now to see all this work that you guys are doing, and you're really on the edge of technology in this area and making ceramic parts by additive. Thanks for coming,
Yeah.
Shawn.
Yeah, you're welcome. Thanks for having me here. Yeah.